Hey everyone, good morning. Hi, I'm Dora Militaru. I work for Fastly, as Dan introduced me. You can find me online in a bunch of places, a little bit about me. So before Fastly, I used to work for the Financial Times, global news publisher. And there I led a team that implemented GDPR. I was on a security guild. So like from the very beginning of my career, I was super focused on performance and security. And I live in London, and I do have a pet fox, like the description says. His name is Franklin. He's hand tame, and I like to put pictures of him in presentations, because why not? So that's Franklin. I hope you like him. And today I'm going to talk to you about the mysteriously titled Zen and the Art of Edge Authentication. So I've written down individually what those words mean. Zen, I'm guessing everybody kind of has a feeling of what that might be. I associate it with being relaxed, and especially not concerned about things that aren't outside of your control. Like, user behavior is very frequently outside of our control. Edge, what is edge? In a context of large-scale coordination-free distributed systems, it is the final point before you hand off to the user, the final point that is still within your control. So in the context of compute, edge means bringing computation and data as close as possible to where it is needed. And finally, authentication is the process of verifying that you are who you say you are. So it's verifying the identity of a person or a device. And it is kind of connected to authorization as well. And authorization means that you have the right or you don't have the right to do a specific action. So we're going to talk today about large-scale distributed systems and secure logging flows. And if I do my job well, you're going to walk away inspired and potentially with a solution to add secure logging flows to your large-scale distributed systems. Oh, sorry, wrong clicker button. Here we go. So where I got the inspiration for this title is a book that I read during the pandemic, a wonderful book by Robert Piercy called Zen and the Art of Motorcycle Maintenance. The whole premise is he is going on a road trip on a motorcycle with his son, and the book kind of starts in a really funny way. He's disagreeing with a couple of friends who don't do their own motorcycle maintenance, because as the title says, the narrator does his own. And his friends think that technology is a death force, and the point of hitting the road on your motorbike is leaving technology behind. So I thought that was kind of amusing. And also, at the time, I was researching a particular topic. I was doing an implementation for OAuth 2 authorization code flow with proof key code exchange on edge compute. And if I put that as a conference title, that's why Ricard thinks security is boring. So we're not going to do that. We're also not going to talk about OAuth 2 today. We are going to talk about something way more cool, because many things happened since the pandemic, many cool things. And the thing that I am most excited about in this space is the fact that we can now have passwordless authentication. So back in June last year, Apple announced at their WWDC conference something called passkeys. And ever since, there's been like a lot of excitement about this technology. And you know what? Like, I haven't read in the newspapers about OAuth 2. And I'm pretty sure that, people who are outside of our professional sphere haven't read in the newspapers about Kubernetes. So this is like a really big thing, and I'm very proud that it is sort of permeated the world outside of our professional spheres. And that's what we're going to talk about today. Cool. So if you haven't used passkeys yet, can I get a show of hands if no one's ever seen this bit before, on the web specifically? Because I know you've been able to use it on your phones. OK, like most of you have used passkeys. So this is just what it looks like. This is a colleague of mine using Face ID on his iPhone to log into a website. You could just as easily use a security key like a YubiKey on your laptop, or even your phone to log in on your laptop. That's a passkey. And once it's registered, this passkey is associated with the website, and that's it. There's no more remembering passwords. And if you stick with me for the next 40 minutes or so, I'm going to give you all the resources you need to get passkeys working end-to-end in like super neat, extremely powerful little package that you can just operate in front of your existing systems, hopefully. And that's going to be as close to your users as possible at the edge of the network. I'm going to explain what all of that means. But if you want to give it a go and let me know if it works or if it doesn't, this is a completely unmoderated real-time chat where all you have to do is register with a biometric or with whatever passkey you want. I'm going to explain in a bit why that's all very secure. I'm not collecting your data. I can't do anything with it, even if I stole it. But yeah, it's my conference demo. If it is a little bit buggy, I did build it this week, so you're going to have to forgive me. I will see if I can get this screen working. So that's kind of what it looks like. Registering a passkey. I'm going to use it on my Chrome profile. Passkeys, you can do them in several different ways. I'm going to talk about that in a sec. It's been my fingerprint. And now I can use it to authenticate. Oh, that's so cool. Thank you for writing. Hey, everyone. Yeah, so if you want to troll, troll there. Don't troll in the questions chat. OK, so before I show you how to do that and share the code and all of that, I'm going to talk about what a passkey is exactly. I'm not going to go into like standard specification level, but I'm going to try and give you the best overview I can. So you might hear some people referring to passkeys as FIDO multi-device credentials. FIDO stands for Fast Identity Online. It's a bunch of companies. It's an open industry standard developed by a bunch of tech companies who all came together to try and make Auth more secure and user-friendly. What is a credential? A credential is a piece of info that you use to prove your identity. So usernames and passwords, these are credentials. We call them knowledge-based credential. Like a password is something that you know. And such kind of credentials are usually stored on a server, and the server is responsible for securing them. And FIDO, they want to move authentication in the direction of possession-based credentials, which is something you have, like biometrics or hardware tokens. And typically, these things are stored on devices that you own. So responsibility for securing them is with the device vendor, Apple, Google, Microsoft, and also with you, which is great if you're an engineer. So like FIDO, anyway, FIDO is like way broader than passkeys. There are so many acronyms. They're not going to go into any of that. I just want to mention that passkeys are specifically and quite controversially meant to be multi-device. So you can verify your identity using the same credential across many devices that you may use because they get synced to your cloud account, to iCloud, for example. There we go. Other people may refer to passkeys as discoverable WebAuthn credentials. Now, discoverable means that passkeys support an auth flow that doesn't need you to enter a username or any other info. Well, in theory, because browser support is still pretty early days for all of this. But it's super exciting that in the future, you're just going to be able to like go to a website, click a button, and you can sign up or sign in like that. Cool. Finally, WebAuthn. WebAuthn is a web standard that's published by the W3C consortium with the guidance of the FIDO people. It uses something called public key cryptography to secure and enable passwordless authentication for web apps. And its associated browser API, it's also called the Web Authentication API, so if there's any web devs in the room, you may have heard of it before. So, quick recap. Passkeys, they're built on WebAuthn. That's a standard, which is a core component of the bigger, broader FIDO standards that are meant to make Auth better for everybody and user-friendlier. Cool. What is public key cryptography? Public key cryptography is a system that uses a set of keys, a pair of keys, a key pair, and it uses this for secure communication and data protection. In every key pair, there's a public key, which can be sent openly through the network to anyone, and a private key, which is being kept secret by one of the parties that's communicating. And this key pair can be used to perform cryptographic operations like encryption and signing. What is encryption? So encryption is something that we use to protect the confidentiality of data. When someone sends an encrypted message using your public key, only your private key can unlock and decrypt or decipher that message. OK, what is signing? Signing is used to verify the authenticity and integrity of data. When you sign something, you use your private key to create a digital signature. So someone else can then use your public key to verify that it is you who, in fact, signed the document, that it is your signature. And also, very importantly, that the data hasn't been tampered with since you signed it. So let's say Bob wants to send a secret message to Alice. Alice has a key pair. She keeps her private key in a safe place and gives Bob her public key. Alice's public key is not a secret, so someone other than Bob can use it, and that's OK. But she gives it to Bob because Bob wants to send her a message. Bob is going to encrypt his secret message for Alice using her public key. Since Bob encrypted the message with Alice's public key, he knows that the only person who can decrypt that message is Alice, because she hasn't shared her private key with anybody else. So Bob trusts that Alice is the only person who can decrypt that message. Now, I did say that Alice's public key is not a secret, so anyone can use it. So someone other than Bob can use it to send encrypted messages to Alice. Now, if Bob wants Alice to be able to verify that the messages come from him, he needs his own key pair. And he can use his private key to sign his messages, and Alice, or anyone with Bob's public key, can then verify that the message they're reading has indeed come from Bob and is exactly as it was when Bob signed it. So these keys in a key pair, they're cryptographic inverses of each other. What the public key encrypts, the private key decrypts, and what the private key signs, the public key verifies. And you only need to keep one of these secret, which is the one on the device. So the other one can be shared everywhere, no worries. And this is exactly what WebAuthn is banking on to enable secure passwordless authentication. And I think it's done brilliantly, and I'm going to explain it. But not before a reference to Zen. It's probably, I think it's the last picture that's kind of Zen-like in this deck. Tea ceremony. So passkey authentication boils down to two ceremonies. In WebAuthn, the flows are called ceremonies, which I think is very cute. So there's registration and authentication. And each one of these involves a choreographed bunch of steps, quite a lot of steps actually, and exactly 4 parties. The user, and the client, which could be the front end, like a website or an application, the server, so backend or an API. The server is called a relying party, and the authenticator, which is whatever cryptographic capability is with the user. So this can be a platform thing, like it can be your phone, laptop, or it can be something cross-platform, like a roaming authenticator, like a YubiKey. So thanks for using the app, by the way. I am touched. I hope it still works. Registration is the first flow that we do. And you can register, you have a choice of things. This is a screen recording of Chrome, by the way. So depending on your device, it might look entirely different. Since I had my last Mac upgrade, it is now possible to have credentials just stored on that device in Chrome, which I think is great. This is just like a little GIF of what happens during the registration phase. You can, at this point, choose to use a biometric, like your fingerprint, or your Face ID, or your Touch ID, or your phone PIN, or you can even use another device. Like, if you see the QR code, I can then scan that with my phone and use an authenticator on my phone. So it's pretty cool how that just sort of magically works. So a passkey is something that's created when a new user registers for an account, or when someone who's already authenticated wants to add a passkey for their existing account. Like when you, OK, I want to switch to like biometric login now. I've had this login for like way too long. And it usually starts with clicking a button, like register passkey. And that initiates a 3-step sequence. That is as follows. So the client requests registration option from the server. That's an API call. So the client requests these options via a fetch to the relying party or the server on behalf of the user. Now, the server is going to generate these options, which is a bunch of data, but usually the name and ID of itself, the relying party. And it's also going to describe what type of public key, which signature algorithms, which authenticators are acceptable. Like, I could adapt that application to say, no, you only need to use things that are on your device. I'm not going to allow YubiKeys, for example. So you can totally do that with WebAuthn. And the server, very crucially, at this point, also generates a random challenge, which it needs to store before it responds to the client with the registration options and the challenge. And now the client is going to call the WebAuthn API. This is the thing in the browser, so it has access to this already. It's not on a server. It doesn't need to go anywhere. It's going to use this function called credentials create. This function passes the challenge to an acceptable authenticator on the platform that it's running in. So this can be, any cryptographic capability on the device. It could be Face ID, fingerprint scanner, YubiKey, could live in your TPM or whatever the equivalent is for Android. And after that, the user might get prompted for verification. Like, not always. If they've just verified it, then they're not going to get prompted for verification immediately a second time. The relying party, when they send the options, they're basically directing what needs to happen in the whole process, and it has that power. So you might or might not get prompted to put in your passkey at this stage, if you're the user. If you can successfully verify, like if you successfully put your finger on there and your fingerprint is accepted, the authenticator, which again is like the cryptographic capability that you have, it creates the key pair, so the private key and the public key. And it associates that exclusively with the relying party, so with your server. The private key is stored on the user's device inside the TPM if you're on desktop, or like the secure enclave if you're mobile. And the private key is going to be used to sign the challenge from the relying party. So signing secret, right? Good way to remember which key does what, is they start with the same letter. The matching public key, a credential ID that identifies this public key uniquely, and the challenge that was signed with the matching private key are then returned to the client. And the client is going to forward all of those three things back to the RP. The server is going to use the public key it just received to verify that the challenge it stored earlier matches the signed challenge it just got from the client. And if everything looks good, the public key and credential ID can now be associated with the users and stored for future authentication flows. And that's it pretty much for like the passkey registration ceremony. And authentication is sort of beautifully symmetric to this. There's not a lot more explaining to do. It's this like back and forth dance between the client, the relying party, and the authenticator. I demonstrated earlier, so I'm just going to skip all this. But yeah, usually it starts with a trigger by the user on the client. It could be like click of a button, sign in with a passkey. And the client is going to request authentication options from the server again. So not registration options this time, authentication options on behalf of the user. The server is going to generate these options. And the server at this point knows, OK, like I have these bunch of keys stored, so maybe don't send them to me again. So the server creates this response and generates another random challenge, and it stores it and then responds to the client with the authentication options and the challenge. The client then again calls the WebAuthn API with credentials.get this time, not credentials create, because presumably we already have credentials at this point. And then it's going to pass the challenge to an acceptable authenticator, which is on the device or on the platform it's running. And at this point, the user might again get prompted for verification with a biometric or a PIN or an unlock pattern, whatever. Sorry, it keeps happening. And the authenticator is then going to use the key that is stored to verify the signed challenge and retrieve the credentials that it stored before. And if everything has checked out, the authenticator is just going to sign the challenge it received from the server. It's going to send back the credential ID that was used on the passkey that kicked off the entire process. And it's not going to return the public key again because, we're expecting that by this point, the server will have stored this already. And finally, the client sends everything back again to the server. And the server is now going to check if the username and credential ID are known. And if so, it's going to look up the original challenge that it sent, like with the options at the beginning. And it's going to look up the public key that it's supposed to already have stored. And it's going to validate this signed challenge. And that's called verification. So if verification is successful, the server is basically okayed to sign in the user and create a session or hand out an authorization token or whatever it chooses to do. Basically, at this point, if you're on a server, you know that the person or the client who is browsing has verified that they are who they say they are in a cryptographically secure way. Cool. So this is like, by the way, I already did this like Zen and the Art of Edge Authentication talk in the OAuth incarnation, which is another standard. It's like way older. And I always include this part, because every few years, an organization called the Open Worldwide Application Security Project publishes an awareness piece on web security risks and vulnerabilities. And this is called the OWASP Top 10. So in 2023, and this is for many years running actually, the top 2 most critical web security risks are associated with broken auth. So it's broken object level authorization and broken authentication. So we have been consistently bad as an industry at getting this right. And it just goes to show that it's very easy to get auth wrong. That's just because there are like so many ingredients, so many standards, and so many moving parts that are necessary if you want to build a truly secure system these days. And authentication, for those who are implementing it, tends to be like scary and difficult and dangerous and essential. And because you need to put it like everywhere. And authentication needs to be just one of those things, not all of those things. So how safe is the WebAuthn and passkey stuff anyway? Because one of the crappy things about password-based auth is the fact that a password is a shared secret, right? You share it with parties that are outside of your control, like as a person, you share it with the server or the public Wi-Fi. And then if a hacker manages to steal your password, they can impersonate you and like fully impersonate you and buy random stuff from Amazon. And like massive data leaks and targeting phishing attacks are a thing. And I hope they don't happen to you, but they will. So passkeys, not cool. Passwords, not cool. Are passkeys vulnerable to the same sort of things? No. Because a passkey doesn't need to leave your device to sign you in. So if someone breaches a relying party server or is listening in on the airport Wi-Fi, they're only going to get your public key. And that is totally fine because it's in the name, the key is public. So when you register a passkey on a website, it is tied to that site's domain. If a phisher is going to trick you into registering a passkey on a fake website, those credentials will only work on a fake website. They can't do anything with those credentials they just stole from you. And the credentials on the legitimate websites, they're bound to that origin. So passkeys are effectively safe from push phishing attacks, from a lot of the pitfalls, like never mind human error, never mind the people who reuse their password for everything. Passkeys are just like such a clever concept and so much better than what we used to do in the olden days. So, are they actually better and nicer to implement than what we used to do in the olden days? So, authentication is critical, and it often needs to be everywhere, as I said. So you want to do it really, really well. Generally speaking, the best kind of auth solution is one that's distributed and fast, so it shouldn't add latency or bottlenecks in your system, and it definitely shouldn't add friction in the user experience. Good auth is also autonomous. You want it to be isolated from the rest of your system because it is so critical, and you also want to limit that surface of attack. Unnecessarily good auth is secure. And ideally, it also should be minimally annoying to integrate and maintain. If you've ever done one of the other types of authentication flows, you'll know exactly what I'm talking about. So this is where edge compute comes in. This is what my colleague Danny was speaking about at the beginning. Edge compute is one of the technologies that I am most excited about for the near future, for the distant future as well, but what the heck is it? So we're in a DevOps conference here, and everybody here can appreciate that large-scale, coordination-free distributed systems are hard to do well. And all the moving parts are really hard to reason about. And if you remember, cloud computing tried to solve for this with serverless. Edge compute is like moving a step even further from there. It tries to go all the way. And it does so by bringing data and computation as close to the end user as possible instead of in a centralized cloud-based infrastructure. So what about this edge compute? There's a bunch of edge compute technologies out there. Lambda at edge, for example, is one. But I'm going to be talking about Fastly compute, which I think will become clear why I am the most excited about this over anything else. But I'll give you a brief introduction, not going to repeat anything that Danny said. So Fastly is an edge cloud platform. We've got from CDN to network services security to serverless compute. Essentially, you can think of Fastly as an extension to your infrastructure. It's a really huge network. It's like 97 points of presence, or POPs, around the world. And it's got a really huge connected global capacity. And over 80% of people on Earth are within 20 milliseconds of Fastly. And the edge, in edge compute in this case, is the edge of Fastly's network. So all the high-powered Fastly servers around the world, you can use those to run your logic on this platform called Fastly Compute instantly everywhere. So basically, it's like having super fast serverless that is always on. You get instant global scale when you deploy, and you don't have to worry about infrastructure or scaling concerns. You don't have to solve for those at all. And the really special thing about it is that every request is serviced in its own isolated runtime environment. There's no reused instances like you get with Lambda, for example. And you get really good security guarantees on Fastly Compute. And that's all thanks to a small, self-contained assembly-like language called WebAssembly, or WASM for short. I'm not going to insist too much on this technology. You can always catch me. I will chew your ear off about it. I think it deserves its own conference talk. But just imagine WebAssembly, it's like this really secure sandbox that you can run your code inside. And it's super fast to spin up WASM applications. Like less than 50 microseconds fast, like not even a millisecond, tiniest fraction of a millisecond, 50 microseconds. So there's no cold boot or cold start or hot start or warming up, none of that. It's just like consistently fast. And that's really helpful when you need the sort of cryptographic operations that you need to do when you want to do WebAuthn or passkeys. This chat application that I wrote this week, I just thought I would show you the system diagram. It's not really a system diagram because I'm not replicating or worrying about quite a lot of things there, and I've also left something out. But yeah, so the compute layer is the relying party, is the one that does the WebAuthn and serves the login form. There's also something called the KV store, where we store the public keys and the credentials that we get from the user's authenticator. And the KV store is really special in that it is a consistent data store that also runs at Fastly's network. You don't need to set that up. You just, you don't need to worry about like database scaling and all of those concerns. It just works. And if anyone here is familiar with CRDT, which is conflict-free replicated data types, it's kind of built on that, except my colleagues have managed to get it to global scale, and it's a little bit above my pay grade to explain exactly how that works, but it's pretty good. So you put your public keys there, and they just get replicated all around the world. No need to do anything on the side of DevOps or your engineering efforts. And all the users wherever they are in the world, can just come in and use this like fast, secure, powerful authentication feature that you can just stick in front of whatever you have. So like the chat app, that was a glitch application, a very simple like Express server if you're into JavaScript. I usually do Rust, so forgive me if I say anything that's wrong. But it's this like simple application with an API. It talks to an SQLite where it can save the messages. Of course, we could save the messages in the KV store. That's totally acceptable way to do it. But anyway, this is just like, I just wanted to make it work with a separate backend. So this is like entirely self-contained, real-time chat thing. And the really special thing that I left out from this slide is actually Fastly takes care of the real-time stuff as well. And we do that through Fastly Fanout. And Fastly Fanout, like the name might let you sort of guess, fans out. It's like a pops-up messaging platform, and it just fans out all the real-time functionality on top of GRIP, which is the generic real-time intermediary protocol. You can also do it via WebSockets. So we do all of that stuff at the edge as well. That's another thing if you're building any kind of real-time functionality that you don't need to worry about. And I made the code available. There's a QR code up there. There's also, that's the chat app. And over here, I have put in some more helpful resources. I think I included passkeys.dev there, which is something that the FIDO Alliance and the W3C people update quite regularly. And it contains a full list of like implementations. It contains a list of browser and vendor support. I've put in the source code for the application that runs the chat and for all the edge compute stuff. And if you've never heard of Fastly before, if you've never heard of edge compute before, I really recommend that you just sign up and experiment for it, because it's free. And you can get up and running. You just have to install a CLI. And the project is set up in such a way that you can put this like WYSI biometrics passkey authentication in front of whatever you want with a config line change. And if I can manage to do this, because Alt-Tab doesn't quite work so well. All you would change is a TOML configuration file before deploying. You can have like self-contained, passwordless authentication. Of course, you're going to want to adapt that to whatever like current authentication your system uses. But it's like super friendly, and I want you to know that it's easy to do. I want you to feel that it's easy to do and not scary. And this isn't something that you can get wrong. There's no secrets to pass around. There's no secret storage to set up. There's no data to leak. This is something that you could just do now, and it is at the bleeding edge. Passkeys, the first public demonstration was last year. I think it was in October. So this is like super, super fresh. And the industry is still catching up with this, and everyone's starting to do it. And it is the promise of the passwordless future that we all want and deserve. So with that, I want to thank you very much and invite any questions. Oh, and I'm not sure how to get back to the QR codes, but hopefully you took a picture. Thank you.
Yeah, there's a lot of them, so it looks like there's some interest, at least, with all the things. So I guess your colleagues at the booth will be very busy these 2 days, which is great. I'll try to group them, folks, because like there are like 20, but I'll try to group them, right? There's a number of questions around the authenticator devices, right? People seem to be, I don't know, I guess, worried if what happens if you know, the authenticator device is lost. Or if you, for instance, format your computer, you need to like, if it was stored in your browser, you will lose that. How do you renew the keys, or like how do you handle, you know, those devices or things like that?
Okay, that's a very good question. So first of all, if your personal device gets stolen, whoever owns that is not going to have the information that you possess, like your fingerprints or your face. They might have your unlock pattern if that's your security. If that's your security, you should upgrade it. The thing with passkeys, so like I said at the beginning, FIDO, the people who are leading this whole like let's do auth without passwords thing, FIDO is a lot broader than passkeys, but passkeys specifically are supposed to be multi-device. So they sync with your iCloud, they sync with your Windows account, they sync with your Google account. And in that way, you are able to use it on any device that is also synced to that account, which is great, I guess, unless you're the MDM person for a large corporation, then it sucks for you, because a lot of stuff is now suddenly out of your control. But all the platforms, all the vendors, Google, Microsoft, Windows, they've just gone and done it. They didn't wait for us. So this is it. You're now trusting them with your authentication data, which I would argue you were already doing before.
All right. Then there were another group of questions around all this seems to be like single-factor authentication. Like, how do you achieve two-factor authentication or multi-factor authentication? Do you need another application on top, or like, how do you consider that?
It is
or maybe they got confused a bit on that. Yeah.
It is two-factor authentication, if you think about it. There are two things that you need to have. You need to have fingerprints and a device. You need to have cryptography and something in your own personal possession to activate it. So like, it's confusing, and it takes a while to getting used to it. But I recommend, so on the slide that I shared at the end, the first QR code was like a list of reading materials, basically. And the FIDO Alliance, for a standards body, actually do a very nice job of explaining this. It is two-factor authentication.
And like, how are, like, is there anything like that they can do with man-in-the-middle attacks? Like, for instance, if the passkey gets hijacked somehow, like, and it's used from a third party, things like, crazy things like that?
It's kind of, that one's difficult to answer because, again, like, all the trust is placed with the vendor of the authenticator, so the cryptographic capability on the device. This is now out of your control. When you come to implement passkeys from a DevOps point of view, it actually makes your life easier because you're not dealing with any secrets. You don't care if that data gets leaked. I mean, user data, you should absolutely care if user data gets leaked, but if public keys get leaked, whatever. And also, like, at the end, as I said, if I get your passkey for a different website, or if I phish your passkey, I'm not going to be able to do anything with it. Passkeys are tied to one origin or one relying party.
Right, and then like they were thinking, okay, how does all this compare to things like mutual TLS between, you know, two ends?
It's the same principle. Whoever asked that is like, very good question, yes. Yeah. It's the same principle, except you don't do mutual TLS with an end user. The whole initiative was born out of trying to make authentication easier and safer for the consumer. So, you know, from having to remember passwords or use a password manager to just being able to provide a fingerprint.
And I think this covers more or less all the topics that were discussed. Anyway, I guess you can visit Dora's colleagues at the booth, so please, massive round of applause to Dora, who started the event. Thank you.